So we're jumping right into solving quadratic equations, and yes, we will be using the quadratic formula unless you're able to factor it and split it and solve it. But in this case, we'll be using the quadratic formula, and we should know that in order to use the quadratic formula, you want your equation set equal to 0 before beginning. So let's set this equal to 0, and when you do to one side, do to the other. So our new quadratic trinomial equation will be 9x squared minus 12x minus 4 equaling 0. So I actually see that I could factor this by doing square roots. However, I want to practice the quadratic formula. So let's do that. Our a value is 9, our b value is negative 12, and our c value is 4. You know, I want to write these with different colors. Our b value is negative 12, and our c value is negative 4, and our a value is 9. Okay, so let's use a quadratic formula. A quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. And of course, when we use the quadratic formula, it'd be a great idea to rewrite the whole thing, but with parentheses instead of the letters. B squared minus 4 times a times c, all divided by 2 times a. So our b value of negative 12 goes right here and right there. Our a value of 9 goes right here and right there. And our c value of negative 4 goes over here. And let's work on the discriminant. What is the discriminant? It's the value inside the square root. Let's begin with the negative 12 squared. Negative 12 squared is really 144. So let me just write a 144 right here on the side. And then let's think about the rest here. We have, let me highlight. We have negative 4 times 9, that's negative 36, times negative 4. That is actually 144 also, positive 144. So you have plus, give me 1 second. We have plus 144. So this is inside the discriminant. Let me rewrite everything so it'll be nice and clear. The minus minus changes to plus plus. We have a 12 plus or minus the square root of 288, all divided by 18. So the question is, what is the square root of 288? Let's simplify that on the side. We do know that 288 is really 144 times 2. 144 times 2. And when you split that root, the square root of 144 is 12, and the square root of 2 will stay the square root of 2. So instead of the square root of 288, I want to replace that with 12 square root of 2. Here we go. 12 plus or minus 12 square root of 2 over 18. Over 18. Now we can and we should reduce this whole thing. We could reduce 12 and 18 by 6. So if we reduce all three terms by 6, we will end up with 2, 2, and 3, right? 12 divided by 12 divided by 6 is 2, divided by 6 is 2, divided by 6 is 3. So our new and final answer is x equals 2 plus or minus 2 square root of 2 all over 3. And that's using the quadratic formula. And as you could see, that is this answer right here. I hope that helps. Let's do another. Now this question is not for you to actually solve, but it is a question where we try to find out what the discriminant value is, right? It's the value inside the square root of a quadratic equation. So just like before, just like if you were going to solve this thing, you need to label your a, your b, and your c. And normally you would plug it all into the quadratic formula. However, the only thing that they're asking you for here is the discriminant, which I purposely put in red inside the square root. So all we really need is to find out the b squared minus 4ac. And using the correct color coordination that I did up there, b squared minus 4 times a times c will be, let's put parentheses there where we plug in. So b is 7, A is negative 2, and C is negative 3. So what we really have here, guys, is 7 squared, which is 49. 49 minus 2, or minus 4 times minus 2 is positive 8. Positive 8 times negative 3 is negative 24. So our discriminant is really 49, take away 24, which equals 25. So the discriminant is 25, okay? The discriminant is 25. Now, what else does it say besides find the discriminant? We already know the answer is 25, okay, but what else? Then what? That should say describe. I don't know how to spell. That should say describe. And man, my handwriting is horrible. Then describe the number and type of roots of the equation. Okay, so if you look at your multiple choice, the discriminant's 25. All right, that's good. The discriminant's negative 73. That one can't be it. The discriminant's positive 73 can't be it. Negative 25 can't be it. We already know that that's the answer. But just in case for the final exam, if the discriminant is not enough, let's see what else it says. It says because the discriminant is greater than 0 and is a perfect square number, yeah, it is greater than 0 and it is a perfect square number, then the two roots are real and rational. Well, that makes total sense, because if my discriminant is 25, that means that when I do the square root of 25, I get a nice, natural, beautiful answer, 5, and I will be able to add 5 and subtract 5, and it will give us nice answers. So I hope that helps right there. But on this particular question, just finding the discriminant of 25 allowed us to select the only correct answer. One more question on solving quadratic equations. It says solve the equation. If the exact root cannot be found, state the consecutive integers between the roots are located. Okay, so I would try to factor, split, and solve, but I'm already thrown off because of this minus sign, so we might as well jump right into the quadratic formula once again. All right, so the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And when we use it, let's plug it in with parentheses instead of the variables. And of course, your a value is negative 1, your b value is 5, and your c value is negative 7. So let's plug in those b value of 5 right there and right there, the a value of negative 1 right there, and the c value of negative 7 over here. And of course, when we do this, let's begin with the discriminant value. The discriminant value is 5 squared, that's 25. And then you have a negative 4 times negative 1, that's positive 4, times negative 7, that's negative 28. So you really have 25 minus 28. And let's think about, let's write that, not think about it. We have a negative 5 plus or minus, we said 25 minus 28, and it is all over negative 2. So we really have negative 5 plus or minus the square root of negative 3 all over negative 2. And of course, the square root of negative 3, the only thing we could do with that, or the only thing we should do with that, is pull out that negative and get an I on the outside. So we really have x equals negative 5 plus or minus I square root of 2 all over negative 2. So it looks like our answer is imaginary. And let's look at the multiple choice over here. Well, as you can see, the answer is not negative 7. And it's not real answers. So like, let's say this wouldn't have been an I, then you could actually do negative 5 plus the square root of 2 on a calculator, and it'll give you a decimal answer divided by negative 2. And you'll be able to see if that decimal answer is between negative 7 and negative 8, and see if the other decimal answer, when you subtract it instead of adding it, is between 1 and 2. But in this case, we know that these aren't even real answers. There's an I involved, which means that there's no real solution. So that would be the answer to this one. Now, of course, we should state the actual solution, but according to this multiple choice question on the final, just by knowing that it's I, you know that there's no real answers. So that's an option right here, and that would be the correct option.